Um, why do you keep doing that? I bet you there's a lot of people going to be missing from this class. So why? All right. All right. Before I start sharing. No, nobody's on the field trip. So why are they taking so long to log in? All right, good afternoon. Hmm. Okay, here they come. Wednesdays are always such a strange day because you're kind of rushing from one class to another. At least that's how it is for me. Because I had somebody logged into while I was in fifth period. They're already logged in, but they're not logged in now. All right. Well, good afternoon. Good afternoon. If you just stay coming in slow, coming in slow. Half the class is more than half the class is still missing. All right. For those of you who are already here, um, again, I want you to go through the study guide. I want you to finish up anything that needs to finish, but go through the study guide if you already finished everything, and uh, use each of these topics to review for Friday's test. And I'll say more about that once everybody is logged in. Okay, but in the meantime, so pay attention to um, describe, explain, and justify. Okay, be able to, those are the kinds of questions that they ask you to do. So think of it in those terms. And then when you finish one, just click on the next. All right. Good afternoon. Good afternoon. Those of you who just came in. All right. So we are in Canvas. We're in Canvas. And you're doing the study guide, unless you have some things that you need to finish up and turn in. But I think most of you are kind of on top of it. Thank you, thank you, thank you. Because when we come back from break, we only have really 3 weeks, less than 3 weeks. You all don't have an end of course test to do, so you don't have benchmarks. So let me close this up. Um, but we're not going to do All right, and I did that last year. I might still do this, so I might do this for Jamaica. I might change that. Last year when we had the storm that hit North Carolina, we did a project. So this is going to be a project that we'll do after we finish up everything else. I might change this from North Carolina to Jamaica because we looked at what effect did the storm have and looked at all of how environmental science is interdisciplinary and how all of the different disciplines are used to help recover from a natural disaster such as the hurricane that devastated Jamaica. All right, so I'm going to rephrase that assignment. But then our next one is populations, and we'll look at populations when we come back from the break, and we won't get through all of it. So I'm just going to stick with the first two, the generalists and the selected species. And if we can get through those two, we'll just do an activity just based on those two modules, and then we'll save the rest for the new year. Okay, so we will not have since we're testing on Friday, we're not going to have another test in 2 weeks again. So we'll have just an activity that will incorporate these two. I believe I have the gizmo that can cover these two, and then we'll do the gizmo instead. All right, so that's just to give you a broad view of where we're going. Still got some people who just didn't hear that because they're late. But all right. So in any case, what I need you to do today is just study for Friday's test. Friday's test is a Unit 2 exam. It will be in the AP classroom. And it'll be in the same format as the others where you have some MCQs and some FRQ questions to answer. Okay? All right, where? All right, here we go. So this is Unit 2. Oh, and I'll wait till everybody comes in because I do have the video in fact, what time is it? They're late. Okay. All right, I will look at it. All right, they're late. So I'm going to go ahead and start this video. It's on your playlist already. And he's going to touch on all the important things that you need to
As a
know
nurse, you give 100%. At Post University, our 100% online nursing programs are 100% on your schedule.
Nothing
Apply
in
now
life
to go
is
from
free. You
RN
have
to
to
BSN in as little as
put up with
12
these
months.
commercials
Learn more at
because
post.edu.
that's what pays for the YouTube.
Managing parks and recreation is more than maintenance.
Hey everybody, it's Mr. Smeeds, and today we're going to be reviewing Unit 2 of the AP Environmental Science course and exam. If you're ready to think like a mountain and write like a scholar, let's get started. Before we go any further with Unit 2 today, make sure you've got your Ultimate Review Packet study guide printed out and ready to go. As we go through this video, you want to answer the practice questions. Make sure that you really understand the concepts that are covered in Unit 2. That exam MA is just too tough to go into without practicing the writing style that you need in APES, so make sure you're practicing with the mini FRQs at the end of each unit. So on we go into Unit 2 with a short but sweet look at biodiversity. Many of these concepts will be familiar already from your biology classes, so if you want to see where we cover specific concepts, make sure to take a look at the video timestamps here. That way you can pop down to those sections if you just need a brief review. Now the first topic in Unit 2 is biodiversity, and it's one that students think they understand but often don't fully grasp. And that's because the basic definition is really simple. It's just the diversity of different life forms found in an ecosystem. But what we really need to make sure we have down are the 3 different levels of biodiversity and why biodiversity is so beneficial. Remember that the 3 levels of biodiversity are genetic biodiversity, ecosystem biodiversity, and species biodiversity. And these 3 levels are nested within each other, which helps us remember why they're so beneficial. Genetic diversity is the variance of genes or traits found within individuals of a population. So high genetic diversity, or a wide range of different traits, is beneficial to species because it increases the likelihood that if there's an environmental disturbance or a change in that ecosystem, some of the members will have genes or traits that allow them to adapt. So if you have a population of sparrows and then there's a drought that causes the seeds they eat to become dry and harder, high genetic diversity in that population will increase the likelihood that some of them have bigger beaks that can still crack those harder seeds open. Species diversity is the diversity of different types of organisms found in an ecosystem. Now there's a really simple way to measure and there's a more complex way to measure it. Now the easy way to measure is species richness. This is just a count of the total number of different species found in a given ecosystem. But a higher species richness doesn't necessarily mean that an ecosystem has more species diversity. We also want to consider what's called species evenness. This is the distribution or the balance of the population sizes of all the different populations present. So if we look at this diagram, we can see that even though the 2 forests have the same species richness, forest number 1 will have a higher species evenness. Now this higher species evenness is beneficial to the whole ecosystem of forest number 1. That's because if there were disease that spread among one deciduous tree species in that ecosystem, there would still be plenty of conifers or other deciduous species to repopulate that forest. Now if the same disease were to strike in forest number 2, that forest would have the potential to lose 70% of its tree cover if this dominant tree species were susceptible to that disease. Now that would devastate the forest in a way that forest number 1 wouldn't be. So just like genetic diversity is beneficial to populations and species diversity is beneficial to ecosystems, ecosystem biodiversity is beneficial to entire biomes. And ecosystem diversity just refers to the variance in the different ecosystems found in a given area. So the tropical rainforest would have a really high ecosystem diversity. You're going to find ponds, rivers, different types of tree stands, edge habitats where a forest meets an open area, whereas a desert biome is going to have a lot lower ecosystem diversity and be able to support less species richness because of that.
Yeah, you got it. These commercials are so
Your
random.
personal finances start with you, but they support your entire home team. With Thrivent, your money.
So now that we understand why biodiversity benefits ecosystems, let's take a look at how ecosystems benefit humans by making us richer. Now I know what you're probably thinking. Wait, what is going on here? The vegan, bike riding, carbon emission cutting environmental science teacher is talking about exploiting nature for money? But remember, many of the things that we attach monetary value to ultimately come directly from or are dependent on the natural function of ecosystems. Now these financial benefits that we get from ecosystems are called ecosystem services. And in APES, we categorize the different type of services into 4 key categories. Provisioning services are the easiest to remember, and that's because these are things provided directly to us by natural ecosystems. Examples would include things like wood for furniture or houses that can be harvested and sold for a profit. Supporting services are processes done by ecosystems that support a valuable human action, such as agriculture. For example, insects like bees and moths may pollinate a farmer's crops, increasing the amount of produce they can sell. Now the farmer could still produce some food without those pollinators, but not nearly as much. So their profits or their yields are supported by those pollinators. Regulating services refer to the fact that ecosystems often regulate or stabilize climate or other environmental factors, which saves us money from having to pay to clean up unstable conditions. So the fact that trees sequester carbon dioxide can save us money because it reduces some of the expensive consequences of climate change. This could be things such as droughts, which damage farmers' crops, or storm damage, which could damage your home. And finally, we have cultural services, which are the recreational or intellectual benefits we get from nature. So a tourist going to visit the Grand Canyon is going to pay a park fee and stay at a local hotel, which generates revenue. Scientists research ecosystems, and they might write books or reports that lead to valuable products being created. In addition to being able to identify the 4 categories of ecosystem services, we also want to understand how humans can disrupt ecosystem services. A great example would be drilling for and transporting crude oil. So when the Deepwater Horizon oil spill happened in the Gulf Coast of Mexico, a ton of ecosystem services were disrupted. Fishermen weren't able to catch as many fish, and their profits suffered. Mangrove swamps and saltgrasses died, which destabilized the coastline and led to more storm damage. And the tourism industry was impacted as beaches were covered in oil and tourists were less likely to come visit. Now, in topic 2.3, we'll take a look at the theory of island biogeography.
All right, I'm going to pause it for a minute because it looks like it's lagging. Like he's talking, I'm watching him talk on my screen, but I'm watching your screen and it's not exactly the same. So I'm gonna give it a chance to breathe, catch up. In fact, I'm gonna stop sharing just for a second. I'll be right back. All right, so he's covered, like he's on the third of, so we have 7 units in chapter 2. So he's on the third one already. I was trying to see if I could change the speed because he is talking so fast. But couldn't find it. Some of these you can change the speed on things and some of these you can't. Okay. Hopefully it's had its moment.
Super complex topic, but it really just boils down to 2 simple. Let's say we have 2 islands of equal size, but one is closer to the
Okay. Okay, hold on. Now it should come up. There it is. Everything is okay. All right, there we go.
damage. And the tourism industry was impacted as beaches were covered in oil and tourists were less likely to come visit. Now, on topic 2.3, we'll take a look at the theory of island biogeography. This can sound like a super complex topic, but it really just boils down to 2 simple rules. So let's say we have 2 islands of equal size, but one is closer to the mainland than the other. The closer island would be likely to have a higher species richness, just because there are more species capable of migrating to that island from the mainland. The further away from the mainland an island is, the fewer species that are able to fly or swim there. So if we plot distance from the mainland and number of species on a graph, we'll see an inverse relationship between the two. Now, if we look at 2 islands that are the same distance from the mainland, the larger island would be likely to have a higher species richness. This is due to the fact that it's going to have a higher ecosystem or habitat diversity. With more space, there's a greater variety of landscapes like forests or grasslands or ponds. This means that we can have a wider variety of plant and animal species supported in this ecosystem. So if we plot island area and number of species on a graph, we'll see a direct relationship between the two. As the island area increases, so too does the number of species supported by this island. We also need to remember that island ecosystems are somewhat unique in that they're going to offer a narrow range of food and habitat choices to species. This often leads to really specific adaptations where species are adapted to the conditions of these narrow food and habitat choices. Take the dodo bird, for example. This large flightless bird species evolved from a member of the pigeon family some 20 million years ago. Now, because it only inhabited the small island of Mauritius, it didn't have a lot of competition from other herbivores or pressure from predators. This led to an increasing body size and the loss of flight because a small flight-worthy body wasn't advantageous anymore without competitors or carnivores to fly away from. And the problem for these highly specialized species is that because they're uniquely adapted to these narrow conditions, they're often unable to adapt to or compete with invasive species that show up on their island. And this is precisely what happened to the dodo bird when the most invasive species of all time showed up on their island.
Bet you that's human.
As a nurse, you give 100%. At Post University, our 100% online nursing programs are 100% on your schedule. Apply now to go from RN to BSN in as little as 12 months. Learn more at post.edu.
Your personal finances start with you, but they support your entire home
They
team.
really want you to
With
see these
Thrivent, your money
commercials.
can be a force for good for the people, causes, and communities you're most thankful for. Thrivent, where money means more.
Can't get rid of them.
The humans. Now, without getting too graphic, suffice it to say that the dodo bird is not around anymore. And the big takeaway here is that islands are going to have a higher percentage of specialist species than the mainland, and those specialist species are going to be more vulnerable to invasives because they're so uniquely adapted to the narrow conditions of those islands.
Because Arthur is a dodo brain! Because Arthur is a dodo brain!
So as good as DW is at cooking Arthur, this one doesn't really add up. Dodos didn't go extinct because they were dumb. They just evolved on an island with no natural predators, and so they weren't afraid of the humans when they showed up. So maybe the real dodo brains were the Dutch sailors who hunted dodos at a way faster rate than they could repopulate and somehow didn't think that would lead them to extinction. So moving on from islands and dodo brains, we'll take a look at a really simple concept called ecological tolerance. This just refers to the range of conditions an organism or species can tolerate before death or serious injury ensues. So let's start with an easy example that we're all really familiar with, and that's human body temperature. Most of us are sitting somewhere between a comfortable 97 and 99 degrees Fahrenheit. Now there are a few outliers with especially high or low body temperatures, and this is a great example of genetic diversity. But in general, humans have an optimal range for body temperature of about 97 degrees to 99 degrees. This is the range where our bodies function most optimally. We're able to survive, grow, and develop. So what happens if an organism moves outside of its optimal range? Well, the first thing that happens is it enters what's called the zone of physiological stress. So let's return to this human body temperature example. If your body goes above 99.5 or below 95 degrees, you're going to enter a stressed physiological state. You're not going to think or move as quickly as you would normally, and you're not going to be able to remain here for long without serious consequences. If you move even further from the optimal range, so above 106 degrees or below 86 degrees, you're going to leave the zone of physiological stress and enter what we call the zone of intolerance, which quickly leads to death. Now, this is a great time to review why genetic diversity is so important. There's a general range of tolerance that all the members of a given species share, such as this optimal range for human body temperature. But there's also some variation between individuals, and that's due to genetic diversity. So some individuals may have a wider range of tolerance or a wider optimal range than others. And this is how genetic diversity can act as sort of a buffer against environmental disturbance. So if the environmental conditions of a population change, such as the temperature or the pH of their environment, some of the members are going to have a wider range of tolerance due to genetic diversity. They can survive the environmental change and pass on these tolerant genes to their offspring, which allows a new population to evolve that is now adapted to this new condition. Speaking of environmental disturbances, we need to take a minute to review the non-human or natural events that can disturb ecosystems. Now, before you start thinking I'm letting humans off the hook for disturbing the environment, we have 5 whole units dedicated to the different ways that we impact the environment. So don't worry. But for natural events that cause ecosystem disruptions, there's 3 main levels of frequency we need to understand. First, we have periodic events. These are things like rainy seasons or dry seasons that happen with some regularity. Then we have episodic events. These occur less regularly, but they're still occurring with some regularity, especially when the environmental conditions are right. Great examples of these events would be hurricanes and forest fires. They don't happen super regularly, but they are more likely to occur when the environmental conditions are right. And finally, we have random events, which, as their name implies, occur with no rhyme or reason whatsoever. These are things like an asteroid striking Earth or a volcano erupting. However, ecosystems can also be disrupted by slow, gradual changes in Earth's climate over time. The reason Earth's climate changes naturally over time is because the orbit that the Earth takes around the Sun changes naturally over time. The first way that the Earth's orbit around the Sun changes is called eccentricity. This refers to the shape of the orbital path that the Earth takes around the Sun. Sometimes this shape brings the Earth a bit closer to the Sun in its orbit, and sometimes a bit further away. The second is called axial precession, or how much the Earth wobbles on its axis. And the third is the change in Earth's obliquity or tilt. We call these variations in Earth's orbit Milankovitch cycles. Since each of these cycles happens with a regular frequency, they produce regular changes in Earth's climate as a result. Notice on the x-axis of these graphs that we're talking about cycles that unfold over tens of thousands of years. So they produce really gradual climate change. Not the type of change we're seeing right now, which is easily observable in one human lifetime. What scientists have learned from lining up the timing of these Milankovitch cycles with ice core temperature data is that these cycles impact the temperature of Earth's climate by bringing it closer or further away from the Sun, or tilting the northern hemisphere closer or further away from the Sun. Now, don't worry about understanding the intricacies of the Milankovitch cycles. You don't need to go this in depth in apes. What you do need to know is that Earth's climate changes naturally over time, over the course of tens of thousands of years, as Earth's orbit brings Earth either closer or further away from the Sun, or tilts the northern hemisphere closer or further away from the Sun. The other thing we need to remember about Earth's natural gradual cycling of climate change is that it causes a change in sea level. As we can see here, there's a really clear link when we look at the last 400,000 years worth of data on global temperature and sea level. During periods where Earth's climate is warmer, sea level rises due to both the melting of glacial and polar ice sheets and also the thermal expansion of water molecules in the ocean. Now, in the context of ecosystems, let's think about what this rise in sea level and change in temperature can mean. Low-lying coastal ecosystems like estuaries may be completely flooded and may disappear during periods of high sea level. Shallow ocean waters that provide tons of sunlight to coral reef ecosystems may become deeper and light may not penetrate to the bottom, which completely changes those ecosystems. These are the types of ecosystem disturbances we need to think about when we're talking about this slow, gradual cycle of natural climate change. Now,
My goodness. The only good thing about these commercials is that he talks so fast.
As a
Gives you a
nurse,
break.
you give 100%. At Post University, our 100% online nursing programs are 100% on your schedule. Apply now to go from RN to BSN in as little as 12 months. Learn more at post.edu.
Observability goes way beyond dashboards alone. It's about real-world impact. Where it counts.
Now, you may be thinking, poor manatees or coral or other species that are impacted by a natural ecosystem disturbance. But don't forget that ecosystems and organisms can adapt. In fact, every species on Earth is the result of adaptation on the part of some ancestor species forced to change based on natural ecosystem disturbances and environmental upheaval. So the next time you catch a dub in Call of Duty or Fortnite, don't forget to thank Homo habilis for those opposable thumbs. In all seriousness though, let's take a closer look at how this trait of opposable thumbs may have arisen in ancestors of Homo habilis. First, we need to think back to the genetic diversity concept that we reviewed in the beginning of this video. Because of genetic diversity, there's a range of traits, even thumb muscle arrangement, in all members of a population. So some early members of the Homo habilis species randomly developed a new thumb muscle arrangement roughly 2 million years ago. This thumb muscle arrangement allowed for a tighter, more nuanced grip that ultimately led to the ability to manipulate and create stone tools. Now, the prevailing scientific consensus is that this new thumb muscle arrangement enabled Homo habilis to create and wield more efficient stone tools for cracking open animal bones. This gained them access to the energy-rich marrow inside and gave them a huge energetical advantage over similar primates that didn't have this same access to bone marrow. Now, because of this big energetical advantage that opposable thumbs brought, members that had this adaptation survived longer due to access to more marrow and passed on those traits to more offspring. An adaptation is just a genetic mutation, like a new thumb muscle arrangement, that gives an organism a higher likelihood of surviving and reproducing. As we wrap up our review of adaptations here, the important thing to remember is that organisms are either able to adapt to environmental disturbances or they're unable to adapt to environmental disturbances and then they go extinct. Some of the environmental changes that early hominids adapted to were moving out of dense forests and into grasslands. In these new grassland conditions, it became advantageous to be able to stand up. So we see Homo erectus with the ability to stand upright, look around, and survey the environment. It was also advantageous to be able to wield more efficient tools to break open animal bones to get more energy. All of these are great examples of adaptations that allowed species like Homo habilis to adapt to new environmental conditions, survive, and pass those traits on to offspring. And speaking of surviving, look at you, surviving all the way to the end of the Unit 2 review. As we wrap up our review of ecosystems, we'll review ecological succession and keystone species. First of all, we have to remember that there are two types of ecological succession. That's primary succession and secondary succession. In primary succession, pioneer species like moss and lichen start to colonize a bare rock ecosystem when the wind transports their seeds or their spores there. Now, they're able to grow on bare rock because they can secrete acids which release the nutrients and minerals they need from the rock through a process called chemical weathering. This chemical weathering process, combined with the death and regrowth of the moss and lichen, slowly lead to the formation of shallow, rocky soil. This in turn allows other pioneer species like grass, wildflowers, and shrubs to colonize the area. Eventually, the continual death and regrowth of these early successional plants adds more and more organic matter and depth to the soil. This then enables intermediate successional species like shade-intolerant, fast-growing trees to come and colonize the area. Over time, slower-growing, shade-tolerant species of trees like oak and maple grow up and replace the intermediate successional trees and shrubs. We call this community that has progressed through these stages of succession a climax community. These ecosystems typically have large amounts of biomass and support a high species richness. Secondary succession follows a really similar progression of changes with one key difference. There's already soil present. Instead of moss and lichen being blown in by the wind and colonizing bare rock, you have pioneer species like grass and wildflowers being blown in by the wind, and they're colonizing disturbed soil. You see, secondary succession tends to take place after a disturbance that clears out the existing vegetation. This could be a forest fire, a glacial retreat, or even humans abandoning an agricultural field. The pioneer species in secondary succession are still fast growing and sun tolerant, and typically they have their seeds dispersed by either the wind or by animals. And finally, we'll review keystone species. Now remember, a keystone species is more than just an important species. Every species has some level of function in its ecosystem, but a keystone species is one that's so vital to its ecosystem function that if it's removed, the entire ecosystem can collapse. So if we were to lose a keystone species like wolves from a forest ecosystem, the deer and elk may overpopulate. This would lead to overgrazing of the vegetation of that ecosystem, and this could be so intense that other organisms would lose those trees and food and habitat resources. This could even lead to the reshaping of the landscape, as the tree's roots would no longer be there to hold the soil intact, and the banks of rivers might erode without those plants stabilizing the soil along the banks. Other keystone species examples include ecosystem engineers like beavers and mangrove trees. These species shape landscapes so dramatically that they create habitats that couldn't exist without them. The mangrove swamp would be impossible without those stilt-like roots of the mangrove tree, and the beaver pond would be impossible without the beaver dam. And that is Unit 2 in the books. Hopefully you feel like the vocabulary richness of your mind has increased. Maybe you even have some fast-growing mid-successional apes ideas taking root in the soil of your brain. Thanks for watching today, Ape Scholars. As always, think like a mountain and write like a scholar.
Okay. All right, so that's in the okay. I don't know why it just jumped to the the next thing in the thing in the playlist. All right, so I'm going to let you take the last couple of minutes. I don't know how many of y'all were actually paying attention to that, but can't say I didn't show you. All right, so I'm going to check on missing grades. We got like less than 10 minutes left to class. So make sure that you go back. If you have any questions about any of those topics, again, go through the review thing and look at the individual points, because he kind of glossed over everything, but go through the individual questions, because he doesn't write the test, so he would not exactly tell you what questions are on there. He can tell you what's in the unit. So again, you need to go through and read each of those topics for yourself, and make sure that there are no questions or statements that are unfamiliar to you. And Francisco, I did go in and check that 2.7 FRQ. All right, the test on Friday is mixed. It's in the AP classroom, and let me open mine and tell you specifically what it is. But it's like all the others that you've done in the AP classroom, where there are a mixture of, it's mostly multiple choice, and you have 1 or 2 questions where it has a picture or chart. Again, this unit has a lot of charts. So you have your succession pictures that you need to be able to recognize the different stages of succession. You have those that have graphs. So there's a lot of graph conversation in this chapter. You need to be able to read a graph. So there'll be some picture questions that you have to answer. All right, give me 1 minute to open my AP classroom. Okie dokie. Okay, so there are 21 multiple choice questions. And there are and there's only one FRQ, which is good. I always have to grade those FRQs separate to the other part of the test. So that is good. All right, so 21 multiple choice. And again, most of the questions have charts that go with them, graphs like the one he just showed you with the glaciers effect. There's one with adaptations of moths. All of the questions have pictures that you have to so analyze the pictures to answer the question, except the last, I shouldn't say all. The first 12 questions are associated with pictures. The last are individual questions. There's, I should say the last questions have a paragraph that you have to read in order to answer the question. I'm trying to remember to start these early so we don't run into that time zone issue we ran into last time. All right, any questions, any questions, any questions? Because it's almost time to go. If you have no questions of me, you are free to go. Have a good afternoon. Let me check this. I need to see are not here.